All right, Math 35, continuation of the last lecture. I'm making it 2 videos because let's face it, everyone wants to watch a 2-hour video. This is day 26. We're on 15.2. Now we are on arithmetic sequences in series. So in an arithmetic sequence, consecutive terms differ by constant. And we'll call that constant the common difference. I don't have a lot of room right there. I'll put a change color for it. This constant, we're going to call the common difference. And we're going to give it the letter D. And so we've got a sub 1, a sub 2, a sub 3, a sub 4, you keep going. A sub 2 minus a sub 1 is D. A sub 3 minus a sub 2 is D. A sub 4 minus a sub 3 is D. There's actually a general formula for the nth term, but we're going to derive it. We actually did this earlier in 335, but we're going to do it again here because I think it's kind of handy to see where it comes from. Let's say we had the sequence 5, 9, 13, 17, and we keep going. What does D equal here? 4. They all equal 4. So I'm going to write these out as our terms. We've got a sub 1 equals 5. And I got a sub 2. I'm going to write their actual values on the left, and we're going to do some manipulation on the right. I'm going to write a sub 2 as 5 plus 4. And I'm going to write a sub 3 as 5 plus 4 plus 4. You saw this a little bit ago, Davis. 5 plus 4 plus 4 plus 4. So if I wanted to shorthand this, I could say this was 5 plus 3 times 4. Because I've got 3 of them. And I could say this is 5 plus 2 times 4. And while you wouldn't do it, it does help to see the pattern. 5 plus 1 times 4. And 5 plus 0 times 4. There's my D right there. The 5, where does that come from? That's actually just a sub 1. So right now we've got a sub 1 plus some multiplier times D. And we just need to figure out, how does this relate to n? When n equals 1, question mark equals 0. When n equals 2, question mark equals 1. When n equals 3, question mark equals 2. When n equals 4, question mark equals 3. If you like look at what's going on here, we could probably say, not probably, we could say question mark equals n minus 1. So the nth term of an arithmetic sequence a sub n equals a sub 1 plus n minus 1 times d. And doing the first couple terms is pretty easy, right? But like if you wanted the 98th fucking term, do you really want to add 4 98 fucking times? No. So let's do a couple little exercises on finding D. Find D here. A sub n equals 4 minus 3n. And then do B sub n equals 1/3 A sub n minus 6. Or B sub n, sorry. What the fuck? N. N. There's some wonky shit in my notes. Yeah, if you want, write out the first couple terms. Until you notice what's going on. It was as if a million people cried out at once and were suddenly silenced. So on your homework, I opened up all the old homework. Teresa sent me an email saying, so every time I complete an old assignment, I have to do another knowledge check. If it's doing that, it shouldn't be doing that. When I get home, I'll try to go in and figure out what the fuck's going on.
I don't know, the one online when it says 100% and you go back to it, all of it is, it's complete, right?
Well, if you're, yeah, because it says 100%. Quit going back and doing old shit. Trust yourself, Keith.
I'll just check. Yeah, like, well, yeah, well, if you go back and review, it'll show you, and you do problems from the past, it'll show which ones you haven't had reviewed, which is a thing.
Oh, okay.
So it shows there's a little bubble that clicks on it. But every chapter I've had to do the knowledge check for every chapter for sure.
Well, that's every chapter is fine.
I would say yeah.
Every section in a chapter seems excessive.
Yeah, I would say probably it may just be how she worded it, but And it would pull up the ones that I would do on way later. That's nice.
Just write out a couple terms, you'll see it. Or you could do a sub n plus 1 minus a sub n. 4 minus 3 times n plus 1 minus 4 minus 3n. This is 4 minus 3n minus 3, and then minus 4 plus 3n when I distribute. You got to distribute the negative to both. And here I distribute the negative 3 to both. And when I clean this up, that cancels that cancels that, and I'm left with a sub n plus 1 minus a sub n equals negative 3. I'm actually going to do this here on this next one because I don't want to fuck with fractions. So I can factor out the 1/3. And I have n, this comes down to n minus 5. And I distribute the negative, and I've got minus n plus 6. And I get 1/3, and in the bracket is just a 1 left. So 1/3.
I was gonna say, it's the number that's in front of whatever the n value is.
Right, it's the multiplier on the end.
It's kind of like the slope on a quadratic.
It's a good way of looking at it.
So
And we saw that from our formula. Our formula was a sub n equals a sub 1 plus n minus 1 times d. Like if I distributed that, so I've got d times n plus this is my new constant here. There's my d. There's my d.
Well, I was thinking you could just move the d to the other side. You just put the d in front of the n minus 1. Then you have something that kind of resembles.
Yeah.
So
Same thing.
it's kind of it's like,
I was just showing how it cleanly, like if we distributed it, this is just the n thing. This is the constant. In this problem, it was the 4. In this problem, it's 1/3 times negative 6, which would be negative 2. Okay, so other stuff you're going to be doing in this section. They'll probably have you find D a few times. Then they're gonna want you to write the equation a sub n plus. They're gonna want you to do this thing with real values. So let's take a look at some examples. We're gonna say A1 equals 7, D equals -3. Just take that shit and plug it in. Wait, that shouldn't say +1. That should just say a sub n. So a sub n equals 7 plus -3 times n minus 1, which equals 7 minus 3n plus 3. Or a sub n equals 10 minus 3n. Or if you want to put the n first, -3n plus 10. Let me give you guys one to do.
So D value and the A1 value relate to their position on the signal.
A1 is the first term in the sequence.
A1 is the first one. So it's the I. It's not I. Is that fatal?
It's the AI, it's A1.
It's A.
But we haven't done the whole sigma yet. We haven't done that yet.
We haven't done that.
That's series. We're just doing the sequences right now. We're about to do series. The series is actually super fucking easy.
See,
You're gonna be. That's why I said it takes longer to go. Like arithmetic's 5.2 or 15.2 is a short section. This is not a difficult formula, is it?
Not terrible. It's real similar to what we've done for that.
You're just plugging shit in. And cleaning up a little bit. In fact, I would argue it's very fucking similar. And it relates to that slope of the line you were saying. Let's tie this into something you've seen before. Y minus y naught equals m times x minus x naught. If I add the y naught over, y equals y naught plus m times x minus x naught. Doesn't this look very similar to a sub n equals a sub 1 plus d times n minus 1? Similar structure, similar solving pattern. Look at me making connections. That's some deep shit right there. I'm gonna write that down before I leave. I'm pretty fucking pleased with that. Most people don't like that formula, but you do. Most people will remember m equals y2 minus y1 over x2 minus x1. This equation for the slope. All we've done from there is cleared fractions and dumped this 2 subscript. That is literally all we've done. They're the exact same equation. And yet people are comfortable with that one because it's the first one you learn with slope, generally. And other people are like, fuck all that. All right, what if a sub 1 equals negative 2x and d equals 3x? Well, I've got a sub n equals a sub 1 plus d, which is 3x, times n minus 1. So just because it looks weird doesn't mean it's wrong.
Would you pull would it matter to pull the X out and put it in front or and have X?
You could.
3 n minus 5.
In fact, it's probably a cleaner way to do it. And if you have a specific value of x, it's definitely easier to work with. What about something like this? I don't have a sub 1, and I don't have d. So those are things I need. Can we find either one of those with what we have?
Find the slope.
We can find d here, right? How many steps has n gone?
6.
Yeah, n equals 4 to n equals 10 is 6 steps. So we've got 15 plus 6 times d has to equal 39. Because d is what we add each time. So 6d equals, if I subtract 15 from both sides, 24. If I divide by 6, I get d equals 4. That pin sucks. There's a couple ways to find a sub 1 here. One of them is just work backwards. So we could work backwards.
Then we have just the d value. We don't necessarily have the whole equation.
Right, well, I could go a sub 3 is 15 minus 4. So like, that's what I was saying. And we could keep doing that and get 11 and then 7 and then 3. Another way of doing it is going, if I treat n as 4, I can do a sub n. A sub 4 equals a sub 1 plus d, which is 4, times n, which is 4, minus 1. So this is d minus. Or d times n minus 1. Well, here I've got a sub 4, and I know what a sub 4 is. A sub 4 is 15 equals a sub 1 plus 4 times 3 is 12. A sub 1 equals 3. So you can find it either way. If this was like a sub 20 and then a sub 30, I don't want to go back 20 times. This one's pretty quick. It's not too bad. And it's easy to go back. Do I got to go back 20 steps or 19? Like if I had a sub 20 and going back to a sub 1, Am I going back 20 times or 19 times or, like, I'm gonna fucking not feel comfortable if I just jump. But if I did this, I would feel more comfortable with it.
So this equation is n is 3 plus 4 n minus 1.
I distribute the 4, I've got -4 plus 3. All right, series.
And it's better to denote it that way than the previous way.
If you can clean it up.
If it reduces that.
All right, series. So here we're adding up the a sub I. And we're going to call this S sub n. We usually call the summation with an S. This actually has a simple formula for an arithmetic series. It's n over 2 times a1 plus an. This is very much like doing the I equals 1 to n of I and getting n over 2 times n plus 1. Or maybe I should say 1 plus n, because that's a sub 1 and that's a sub n. So it's the same thing. It's very similar. So I'll re-put it down here so that the other shit isn't in the way. This is 100 over 2 times 100 plus 1, which is 50 times 101, which is 50.
Now the total value of the added.
Adding 1 to 100.
A1.
1 plus 2 plus 3 plus 4 plus 5 all the way up to 100. That's a quick hand notation for it.
Right, so you just. Okay,
we're just plugging n into this formula, a sub 1 and a sub n. So here, like, this one's got a little bit more work. Let's say 1 to 1,000 of 3n plus 1. To do this, I need a sub 1 and I need a sub n. Which in this case is a sub 1,000. What's a sub 1? Three times 1 plus 1 is 4. We're just plugging it in. The last number is going to be 3 times 1,000 plus 1, or 3,001. That's a 1,000. So if I'm doing n over 2 times a1 plus an, that's 4. That's 3,001. And that's 1,000. So 1,000 over 2 times 4 plus 3,001. This is 500 times 3,005. Let's see, I got a 0, 0. I want to say that's going to be 15,025, I think. I'm doing that in my head. I'm going to do it in the calculator now.
1,500,000.
Bam!
Yeah, that's correct. Over. So times A1 being the first number of the sequence. And the point in A1 coming from the value that's listed under the sigma.
Yeah.
That's the lowest value.
Yeah.
Under the sigma is the lowest value above the sigma.
This assumes that the formula assumes you start at 1. Okay.
Sorry.
That's important to know.
Yeah, because that can change, right?
We could be sneaky. I'll show you a sneaky one real quick. I don't know if Alex will have a sneaky one. But what if we had like k equals 3 to 10 of n? We'll do a simple one right here with n. Well, this is missing. This is like doing it from k equals 1 to 10 of n minus a sub 1 and minus a sub 2. A better way of saying this is the full sequence would be a sub 1 plus a sub 2 plus k equals 3 to n, or 3 to 10 of n. So those are the missing terms. I don't think Alex is going to do this.
But I mean, does the formula still work? Could we like in the, let's say if it was the previous one, could we still have, instead of A1, we could substitute A3?
No.
We can't do that.
Because the formula is very much dependent on.
So we have to.
Well, it might work. Let's check. Let's check. I'm going to use, we have the formula for this one. So this will be, wait, that should be a K. So we're doing 10 over 2 times 10 plus 1. That's my a sub 1 and a sub n. And then I'm subtracting 1 and I'm subtracting 2. If I follow this formula here. This is 5 times 11 minus 3, which is 52. Let's see if that works with what you said. K equals 3 to 10. Okay. So can I do 10 over 2 times 10 plus 3? No, it's not the same. This is 5 times 13 is 65. It's not. No. I don't think Alex is going to do that.
So then, in order to do this correctly, we can't just change the numbers in the parentheses. We actually have to go for the original format.
Yeah, it's got to be the original format.
And you have to subtract the previous numbers.
Yes. And it comes from looking at it like this, rewriting, because this is the one we have the formula for is on the left. Rewriting it as piece, kind of like we did with factorials, peeling off what we needed on the factorials, peeling off till we get what we need. And then this is what we wanted. So subtract that shit over to the other side. That should be a 2.
And it's not those two numbers plugged into the equation. It's not that. It's just the raw numbers.
Yeah.
It would just be 1 and 2 instead of 1, A1 and A2.
In this case, A1 and A2 happen to be 1 and 2. But if it was like this up here, A1 and A2 are not 1 and 2. A1 and A2 are 4 and 7.
Yeah,
So it's dependent on what you know, it's related to the formula.
So that formula up there only works if you have an A1.
Yeah, it's got to start at A1. Okay.
And you can make it work easy for yourself if the lower number happens to be large. If it's like 1,000 over 100, you could just do the 100 and subtract. Or no, actually, you could.
Yeah. I'm gonna say one more real quick. I know I'm over time, but let's say they just show you some of the things written out. Up to n equals 10. So, what could I do here? Well, that's A1 for sure, right? It's my first number. What's D here?
Seven.
Yeah. Just pick any two numbers, do the consecutive thing, it's 7.
Yeah.
So now we've got D, we've got A sub 1, we've got N. I can do A sub N equals A sub 1 plus D times N minus 1. I've got 5 plus 7 times 10 minus 1. A sub N is 5 plus 7 times 9 is 63. 68. And now I've got A1 and A10. A1 is 5, A10 is 68. I can add these up without writing them all out and figuring out what they are. We've got 68 over 2. No, it's n over 2. Ten over 2 times 68 plus 5. So 5 times 73 is 365. That would be S of N. Now, here, I think writing out the next 10 thing or next 6 things and doing it calculators, probably just as fast. But like, what if N was 100? You know what I mean? So like the bigger N is, the more useful like doing this formula shit is. We'll wrap it up. I'm sorry for holding you guys over. This part is not on your test, which is nice, but